So what happens to our graph of the exponential function and the characteristics if we change that base? So we're going to go from a base of 2 to a base of 3. So we're putting a larger number in for the base. Let's see what happens. Same exact scenario. We're going to build the same XY table, picking the same X values. So -2, -1, 0, 1, and 2. So we'll plug in each of those values. 3 to the -2 becomes 1/9. 3 to the -1 is 1/3. 3 to the 0 is 1 again. 3 to the first is 3, and 3 squared is 9. So when we go to plot those points, okay. So at -2, we're even closer to the axis. At -1, we're at 1/3. At 0, we're still at 1. So that was also consistent with the last graph. We had the point 0, 1. At 1, we're up at 3, and at 2, we're up at 9. So the overall shape of the graph did not change. You are going to notice that it rises faster or is increasing faster with the larger number as a base. Because before, when we were at 2, we were down there at 4, and now we're up at 9. So the output, the Y value, is larger. It does still have this asymptote sitting right on top of this axis. So we still have a horizontal asymptote at Y equal to 0. That did not change. What about the other information? Did any of it change? So our domain, well, domain's still -infinity to infinity. Our range is still going to go from 0 to infinity. It has no x-intercept. It does still have a y-intercept at 0, 1. Let's see what's the next piece of information. The asymptote, which we labeled horizontal asymptote at y equal to 0. It's increasing still, and it is still 1 to 1. So literally the two graphs are almost identical, but not quite. In other words, this one rises faster, gets steeper quicker, and it gets closer to the axis quicker. That's because the larger base is forcing those fractions to get tinier as you go out in terms of -infinity. So there's our graph. So we did 2 to the x, we did 3 to the x. Okay, well, we said you can pretty much use any number you want for that base as long as it's positive and not equal to 1. So let's go use a fraction and see what happens. So our next example, we're going to do f of x is equal to 1/2 to the x power. So we're going to build the same xy table. Trying to be consistent so you can see some consistencies or characteristics. So we have -2, -1, 0, 1, and 2. Okay, so be careful. So now we have 1/2 being raised to the -2 power. Well, the -2 is going to take that fraction and reciprocate it. So that would now be 1/2. I'm sorry, that would be 2 over 1 being squared. So now I'm going to have 2 squared, which is 4. When we plug in the -1/2, that again is going to reciprocate it. That would be 2 to the first power, which is 2. Any number raised to the 0 power is 1. 1/2 to the first power is 1/2. And 1/2 squared would be 1/4. So these are the same values for y, they're just in different spots from what we had a few minutes ago on 2 to the x. So let's graph that. I was really hoping to get it on the same spot, same location. Compare them. Let me squeeze it in over here. Okay, so we have -2, we're up at 4. At -1, we're up at 2. We still have 0, 1. At +1, we're at 1/2, and 1 +2, we're at 4. So it comes in and does this kind of shape. Wow. So when we had when we had a base that was greater than 1, it's increasing. But notice that now that the base is less than 1, it's decreasing. So in terms of our information, what's changed? Well, the domain is still -infinity to infinity. The range is still 0 to infinity. It still has no x-intercept. It does have a y-intercept. It's still at 0, 1, so that didn't change. The asymptote, I didn't draw it in, but it is sitting here. I'll draw it in. It's got a horizontal asymptote at y equal to 0. But instead of increasing, this one is decreasing. It's going down now. So putting in a base that's between 0 and 1 gives me a decreasing function. It is still 1. So now that we've graphed three different exponential functions, different bases, 2 to the x, 3 to the x, and 1/2 to the x, you can see the characteristics of that exponential function at the top of the handout on the next page. So just summarizes everything that we've been saying. And at this point, we're no longer going to plot points. What we're going to do instead is use transformations. And what's important to recognize is the two pieces of information we're going to move are that y-intercept. That's going to be my anchor point. That's what I'm going to move when I start shifting this graph around, and that horizontal asymptote. Those are the two things that we're going to move up, down, left, right, and so forth. So just like when we move the a parabola around the grid, we take that vertex and move it. We'll move that y-intercept. Make sure you read through those characteristics. A good summary of what we've been saying. In example 3, we're going to graph f of x is equal to the x plus 1. So now we have the exponential function, but we're adding 1. Now notice this plus 1 is outside the function, so we know that's going to shift the entire graph up 1. So we're going to take what was at 0, 1 and move it up to 0, 2. We're going to take the horizontal asymptote that was at y equals 0 and move it up here to y equals 1. And we'll draw on our shape. So we'll start right above the asymptote. Once we cross, we're going to head on. And there's our graph. If you want, you can plot one more point. It might not be a bad idea just to get a better picture, especially when you're doing that online homework. You can plug in like 1. So 2 to the first power is 2 plus 1 gives you 3. So at 1, we're up at 3. And that should give you a fairly smooth curve of what to plot. Notice the domain is still negative infinity to infinity. The range is still 0 to infinity. And it has a horizontal asymptote at y. Okay, so we can move it up or down. Okay, what about part B? Says we have f of x is equal to a negative 2 to the x. And again, what this really means is a negative of 2 to the x. Again, the base can't be negative, so it's a negative out in front of this function. Okay, well, what does that do? Well, again, that negative is outside. And we know that when you put a negative outside of a parabola, it flips it across the x-axis. So it's the same thing that's going to happen here. So we're going to reflect across the x-axis. So the point that would have been at 0, 1 is now down here at 0, -1. The asymptote didn't move though, because we didn't do any shifting up or down. The asymptote's still going to be at y equal to 0. So we're going to come in right below that asymptote, cross at our anchor point, and head on down. Again, you can plot another value, plug in our +1, you get -2. The domain is still negative infinity to infinity. The range is still, oh, wait a minute. We're starting down here on the bottom, so it's going from negative infinity and stopping at 0, excluding this. So we can move it up or down. We can reflect it top to bottom. We've already reflected it left to right. So the only thing left to do is to move it left to right, and that would be part C of this example. On example 3C, it asks us to graph f of x is equal to 2, and then as the exponent in the exponent is x minus 1. So this is now inside the exponential because it's up there inside the exponent. That's why it's inside. So we know that when we're inside the function, we do the opposite of what it says. So instead of subtracting 1, we're going to add 1, which is going to shift right 1. We'll pick up our picture and move it right 1. So the point that was at 0, 1 is now going to be over here at 1, 1. Because we're shifting it right, nothing happens to that horizontal asymptote. It's going to be right on top of that axis again. We're going to come in right above it, cross at the 1, 1, and head on out. So you can plug in 0 here, and in order to get that y-intercept, you let the function equal 0. Not going to help us yet. Not yet. It will eventually, but not yet. So we can't find that y-intercept quite yet. The domain, though, is still negative infinity to infinity. The range is still 0 to infinity. So none of that has changed. Okay, so there's all of the different transformations that we've practiced in the past. Okay, on the next page of the handout, what you're going to see is a lot of writing. We need a base of an exponent that's between 2 and 3, and it just happens a lot both in nature and, believe it or not, in finance. So we need a base that's somewhere between 2 and 3. We define this number based on the following expression. The expression we use is 1 plus 1 over n to the nth power. And so you're going to see the exponent. Right? So the expression is 1 plus 1 over n to the nth power. So it's still an exponential function. You've got a variable sitting up there in the exponent spot, but that same variable is sitting over here underneath 1. So what I've done is I've built a table using the graphing calculator, and you're going to see different values. So we're going to plug in different numbers for n and then see what the output is. And you're going to notice when you look at that table, look at the right-hand column for the outputs, that this number approaches or becomes the value 2.71828, and it goes on. It is an irrational number. It's a number that does not repeat and does not terminate or end. So it's an irrational number, and we call this irrational number e. So just like pi is 3.1415, whatever it is, right? It's an irrational number. Here's another irrational number that has the same flavor, and this is where it comes from. So it's e. It is built into your calculator. It's in a couple of places. So when you look at your graphing calculator, you have a key that's marked LN. Right above that LN is an E with a caret. So that's your E. So figure out what E is. You're going to do second LN. That'll give you this on the screen. And then you just type in a 1. And when you do that, you'll get this 2.718281828, and then it goes on and on and on. Again, it does not repeat. So even though you might see a pattern, that pattern doesn't continue on. So, okay, let's graph it and see what happens. So again, we're going to build a table of values just to get a feel for it. So this is example 4. We're going to use that key on the calculator to graph f of x is equal to e to the x. So here's our x, here's our e to the x, and we're plugging in -2. If we plug in -2, we get 0.135, and you should be checking these on your calculator. If you plug in -1, you get 368. Plug in 0, we already know it's 1. If we plug in 1, we get that 2.718. If we plug in 2, we get 7.381. Okay, we go to graph those. We expect the same shape. The only thing that's changing is the actual outputs. So at -2, we're fairly close to the axis at 0.1. At -1, we're a little bigger, 0.3836. 0 is still at 1. At 1, we're up at 2.7. So 2.7 is not quite 3. And at 2, we're up at 7.3. So 1, 2, 3, 4, 5, 6, 7, 8. So 7.37. So the graph has the same exponential shape, has the same horizontal asymptote. But if we graphed 2 to the x and 3 to the x on the same grid, we're going to see that sure enough, this graph lies between the two. So we know that when we did 2 to the x, we ended up with a value of 2. We did 3 to the x, we ended up with a value of 3. So you can see how this 2.718 is between 2 and 3. So it's definitely a function that fits what we